Hello, hello. Today I'm going to help you get started with data science and visualization. We're going to be going through a library that's super cool called plotly.express. So yeah, I think we should just dive into it. Today you're going to get some experience with visualizing real world data. So we're going to have some results today that you can go and take into business analytics or coding or any other data science project. I really love the Plotly Express library because it makes beautiful interactive graphics super quickly. So without further ado, I have to introduce you to my puppy Leo. He's going to be helping us today. Isn't that right? He loves data science, so I do this for him. Well, we're going to start with this environment called Google Collab. If you haven't used it before, I'll kind of dive into a little bit of what it is. But basically, it's a coding environment that you can use to code in a browser so that it's completely independent of whatever computer you're using. Seriously, guys, you could use a phone to run today's tutorial. All you need is the link, and you can share that link with others, and then they can collaborate with you in this document as they would, say, Google Sheets or Google Docs. So what is Google Collab? Well, basically, let me minimize this a little bit. Basically, what we have is a Jupyter Notebook. A Jupyter Notebook is a software, it's an open source web application that allows you to create coding documents that also have text in them. And so it's really good. It's necessary for data science because in data science, you're normally trying to tell a story. You're not as much building like an application with code. And so Jupyter Notebook is great for that. So what Google Colab does is it just takes this Jupyter Notebook software or environment and just hosts it in the cloud along with some additional bells and whistles. But basically Google says, hey, instead of running Jupyter Notebook on your own computer where your OS may make it mess up, why don't we just host it in the cloud for you and then give you a link to it? So it's free. It requires no setup, which I absolutely love. It's great for tutorials. You can write and execute your code. You can share it with other people. You can also, a really nice thing about Google Colab is that you can access the GPU. So if you want to know how to do that in Google Colab and take best advantage of the resources, watch out for that video that will be coming up. But yeah, today I'll be just showing you how you can be using Google Colab for visualization. So basically, if you've never used Jupyter Notebook before, there's different cells. So a cell could either be a text cell, in which case you can write just plain text, or if you create a new cell, you can make that a code cell. And in that one, that's a code cell is executable. It will run your code. And so a Jupyter Notebook or a Google Colab, I'll kind of use them interchangeably because really Google Colab is a Jupyter Notebook that's just hosted in the cloud. So yeah, in a Jupyter Notebook, we have these text cells, code cells, and then we'll have output from the cells, which may be in the form of text or maybe a visualization like it will be today. Just real quick, why are we using Python for this? Why not R? Great question. I've used both, but more recently, data science, as this graph is showing, is really taking a liking to Python, especially for my general role is if you think your project is going to be more machine learning heavy, then I would definitely recommend Python. If you think it's going to be more statistics heavy, then I would consider R. But today we're going to be doing Python. So let's just jump in. So we are using a library called plotly.express. Plotly is a pretty configurable visualization library, and Express is just built on top of that to make super simple visualization really beautiful. So here we have, I'll just kind of talk through line by line what's going on. By the way, if you want to run these cells, you don't have to install anything. The link for this new notebook is in the description, and you can just open it up and then there might be a box that pops up that says, this notebook is not approved by Google. You just click run anyways, and then just select a cell that you want to run, one of the code cells, and then you can press this play right here, or if you need a shortcut, you can press Shift and Enter. I like that one. Okay, so let's get started with a really simple plot here. Maybe you've seen this data set before. If you've spent any amount of time learning data science, you definitely have. It's a real really fundamental data set in data science. But the idea is you have these flowers that some measurements were taken, and it's generally a classification problem. Given the sepal width and sepal length, I guess sepals, yeah, like kind of the size of the flower, but leaf, whatever. I'm not a botanist. But yeah, given like the width and length of these flowers, can we identify what type of flower it is? So you always kind of want to start data science with visualization before jumping into the machine learning. You really want to start and end data science with visualization. It's that important, because without visualization, you just don't really know what you're getting yourself into. And then without visualization at the end, you can't show off your results. And people don't really, think in terms of numbers, especially if they haven't been in the data. They just want to see a nice graph. So what we see here is it's super simple. So we've read in this data set called the iris data set from plotly.express. And if you want to know what other kinds of data sets they have, you can list that. You can list the data sets. But yeah, so it loads the data set into what's called a pandas data frame. And if you've never used pandas before, watch for that in another video. That could be a video on its own. But basically a data frame is what you would expect as an Excel sheet. So just think of like a data frame as an Excel sheet that's stored in a variable. Okay, it has column names, it has row names. So this data frame is like an Excel sheet. It has column names. Those column names are sepal width and sepal length. It also has a column called species. So what this is doing behind the scenes, Express like abstracts a lot of what it's doing, right? So it's taking this data frame and it's saying along the x-axis, take the column that's sepal width, and along the y-axis, take the column that's sepal length. Just so we can see the data frame, let's show it here. Okay, so this is the data frame. We have a sepal length, width, and a few other things that we're not visualizing here, right? Notice that there's a species column, and that species column is a nominal or categorical variable. So that's important to realize there's differences between numerical variables and categorical or nominal variables. So these are obviously numbers. This is a category, right? So let's uncomment that and plot this again. So when we pass the color parameter as species, what's that doing is it's coloring, it's categorizing the data into these bins according to species, and then coloring them just some random color. And so we can easily see, you can already see if you were to do some clustering, it looks like this blue one, which, let me move my video here. Over here in the legend, it says species equals Setosa. So it looks like the Setosa flower is just given these two factors, these two features, it's pretty easy to separate from the other classes, right? So if we were to run a classifier, we'd expect that our classifier would do pretty well on classifying the Setosa species, given these two features. So see, that's why visualization is so important, because if we didn't do this visualization, we might not have the intuition. And so we wouldn't know, hey, our model's doing good or bad. So we're gonna just move right on. Okay, next we can combine plots, which is really cool. So if you hover over, another really thing I love about Google Colab is that, if you were running this, say, in a Python script, you might type out px.scatter, but then you'd have to look online for documentation for what kind of parameters you could pass to it as a function, right? But here you can just hover over any of these functions and get all the parameters that you can pass into it. And you can actually view source, and it will pop open the actual source code for this. And sometimes there's like good documentation too. It doesn't look like there's a lot of documentation here, but so that's pretty cool. So if you were to hover over it, you would see that you could also pass in some additional parameters. Here, there's a parameter called marginal Y, marginal X, trend line, and template. So let's talk through what all of those are doing. Well, a violin plot is a great way to see a distribution. And so if we want to see a distribution of our data, what values of sepal length do most of our data take on? Per class too, we could do, right? So what we're seeing here is that the most of our data is right here around sepal length of about 5. And it actually tells you all these statistics, which is really nice. It has a median of 5. And yeah, so we can see, and it kind of looks like a normal distribution actually, for what I'm seeing here. It's just take like a normal distribution and then reflect it. And so that's kind of what a violin plot is. This data I would say is, what is that, right skewed? And this one's, I would say, pretty normal distribution. This one's right skewed because it looks like we have an outlier down here that kind of gets us that part of the violin plot. Up here is a similar way. It's kind of like a box plot if you've ever used that before. So it's just a different way of showing similar data. You have your min and max, or box and whiskers. You have your min and max. You have your median and your quartiles, your first and third quartiles. So yeah, if you haven't done like box plots before and you don't really know what quartiles are, we could maybe do some videos on that. Let me know if you want that, or we could you could go look it up somewhere else. But yeah, so obviously very powerful. You combine these visualizations and you can see there's a lot of information going on here. Let's see, we actually have to talk through this. Trend line. So OLS means ordinary least squares. That's basically just telling it, hey, draw a line through my data for each color that will, the line is meant to reduce the least squares between, well, that's another video too about how we fit that line, but it's intuitive, right? Like this is a trend line. It seems like in this class, as sepal width grows, so does sepal length. Cool. We are going to do one more plot today, and then we may open it up to more discussion later. So here is a scatter plot, which is similar to the scatter plot above, but now we actually pass in error. Okay, so we can see that there's an error in the x direction, which is the sepal width divided by 100. So as the sepal width grows, you can see how the error bars grow. They kind of look like little Star Wars, the fighters, or what are those called? Forgot. But yeah, so you can actually like show people not only, so this is kind of like a dummy way to show error. There's in this data set, there's no real measurement of error, but say that there was another column that was, error in the measurement. Often in real world measurements, there is error, or in calculations that we do, that error can accumulate. And so we need to be clear about, well, this is, we took this measurement of sepal width and sepal length, but, give or take like this amount of tolerance, because maybe we used a, our phone to measure the distance and it's not super accurate. So that is what the error bars are for. So, I mean, that is just, we've just gone over the scatter plot. Guys, there's so much more. If you stick with me, there's bar plots, there's, we can make a lot of plots in one. There are these crazy line plots I'd love to dive into. And and then we'll get to, pie plots. But where it really starts getting interesting, that I love, are these interactive type plots. Some of these you can actually interact with to change the plots dynamically. And there's heat maps, guys. There's so much here. There's maps that you can plot data on. So really dive into plotly.express. You'll definitely be upgrading your visualization game. And I'm excited to get started on more coding with y'all. See ya.